Welcome to the High-Tech Crime Institute video training series. Today we will be talking about how to image a newer computer that has a UEFI interface and the Windows Secure Boot feature. So what is UEFI and what is Windows Secure Boot? And we're going to talk about both of those systems. And first of all, let me read you a definition from the most trusted source on the internet, Wikipedia. And it says basically the Unified Extensible Firmware Interface, or UEFI, pronounced as UEFI, is a specification that defines a software interface between an operating system and platform firmware. UEFI replaces the basic input-output system firmware interface originally presented in all IBM PC-compatible personal computers. With most UEFI firmware implementations providing legacy support for BIOS services, UEFI can support things such as remote diagnostics and repair of computers even with no operating system installed. So this adds a new layer for the forensic investigator between the boot and the operating system itself. There are some unique things that are going to happen now with this UEFI and Windows Secure Boot. We're going to go ahead and let Microsoft explain how Secure Boot works, and then I'll come right back on.
You've been surfing the internet and downloaded a new game that everyone's talking about on your favorite social media site. What you don't know is when you install the game on the next reboot, it modifies the boot process such that malware-based versions of an OS loader starts before Windows. This malware OS loader then loads Windows so you never realize it's on your system and that your system is compromised. Because this malware was running before the OS was loaded, your antivirus and even Windows knows absolutely nothing about it. Windows 8 addresses this with a UEFI, which is a modernized replacement for traditional BIOS. UEFI will check the signature on the OS loader when it starts the machine and compares it to a list of approved signatures that are stored in a protected space within the UEFI chip. Because the malware loader is not signed with an approved signature, the UEFI chip will not allow that malware to load. Because I have UEFI and its secure boot feature on this machine, you can see instead of an infected machine, I get an error screen warning me of the problem and asking me to get assistance to clean it. So we have Secure Boot ensuring that only valid, signed operating systems get loaded. But what about the critical files for Windows like drivers and system files? To protect those more securely in Windows 8, we've introduced Trusted Boot.
So the issue that's been created by using the Secure Boot and the new UEFI is it blocks me from using some of the Windows Forensics tools that I have in my toolbox. So now what I have to do is I have to come up with an alternate process or a different method of being able to connect to the internal storage, especially on these newer laptops that are coming out, the cheaper ones that don't really have a hard drive in it. You have a chipset that's on board that acts like a hard drive. It's more of a flash drive environment. These are going to be the issue, or the types of computers that we're going to have this issue with. So there is a workaround for this, and I'm going to take you into something called the Windows Forensic Environment, and we'll walk through the workflow of that environment. The workflow processing is going to take us into loading the different types of boot media. The first one that we're going to look at is the Linux system. So we're going to take the Linux thumb drive or CD, and we're going to hit the drive we were trying to collect, and the chipset is not going to recognize that Linux system, and therefore it's going to deny us access to the hard drive. This will give us the opportunity to then create the WinFE, or the Windows Forensic Environment CD or thumb drive. When we load the Windows CE or Forensic Environment thumb drive, this is going to allow us to hit the system. The system's going to recognize that this is a legitimate Windows OS because we are bringing it in from a Windows 8 CD. So it's going to recognize the Windows 8 signature, and it will allow us then to bypass the Secure Boot protection, and we'll be able to collect the drive at that point. And this is the advantage of being able to use the Secure Boot or the Windows FE in that secure boot environment. The program we're going to use to create our ISO image, or the image that we are going to build our thumb drive from, is a program called WinBuilder. And it's designed to create packages that are Windows compliant. As you can see on the left here, we have different packages that we can include. For example, FTK and FAU and other forensic tools. By clicking the play button, I'm going to go ahead and start creating an ISO file. Now it's going to ask me for the Windows 8 file, so I need to make sure I have a CD or some type of device or some type of operating system, Windows 8 or Windows 10 media, so that it can copy out the necessary files for the Windows 8 and Windows 10. This is very important because it's going to need those files when it goes to boot the computer. And as you can see, we've gone from 2 to 23 very quickly, and that's because we shortened the video, not because the program is going very fast. This process can take anywhere from 3 to 5 minutes, all depending on the amount of programs that you're going to include. Once it's done, you can verify that the .iso image was created, and to find the .isos, I'm simply going to go to the output path that I designated in my application. So I'm going to go down here, I'm going to find my WinFE, then I'm going to find my .output folder, and inside my .output folder I'm going to find my WinPE ISO. Once our ISO image is created, we're going to use Rufus to actually put the ISO onto this thumb drive that we're creating. You can download Rufus from rufus.akeo.ie. The website is on your screen. And once we download Rufus and install Rufus, Rufus will allow us to create or make our bootable thumb drive. So I've launched my Rufus program here. And first thing I'm going to do is I'm going to select the ISO that I want to put on. Now I'm going to choose the WinPE ISO because that's what I just created. I'm taking that out of my .output folder that's on my desktop. I'm going to go ahead and select that. And once that's selected, it's going to come in and it's going to appear in my Rufus. Now I'm going to choose the drive that I want to make bootable, which is my Lexar 64 gig. I'm also going to choose the type of partition. This is extremely important. Make sure you use the GPT partition for UEFI. Do not use the default. Use the UEFI. And also make sure that you choose a large FAT32 by default. Once you've done that, you can leave the name WinPE and you can come down to the Start button. When you click Start, Start will attempt to start building your drive. If it has any problems, it will give you error messages. It's going to come up and tell you or ask you if you know that you're about to lose all your data on that drive. Of course we do, as we're making boot drive. And we're going to go ahead and allow Rufus to format and then copy over that WinISO file. So we have all of our items on there. Now it's time to go ahead and capture the laptop. So I'm going to go ahead and make sure the power is plugged in. We're going to make sure that we have our bootable thumb drive, and we're going to go ahead and install that bootable thumb drive into the computer. This one happens to be on the right hand side. We're also going to make sure we have our collection drive, and I have my collection drive here, and I'll be using that a little bit later on once we get the system booted up. At this time, I'm going to go ahead and press the power key, and after pressing the power key, I'm going to go ahead and press the escape key several times until the boot manager comes up. Once the boot manager comes up, I'm going to press the F9 key, and the F9 key will launch the boot manager. And notice that I have the option for our USB hard drive, UEFI, and next to it says Toshiba Trans Memory. Since I have a Toshiba thumb drive, that makes sense. So I'm going to go ahead and boot my computer from the thumb drive, and notice it came up very quickly. We have a little time lapse going on there. I'm going to make sure I put my collection drive into the computer. This is the time that you will need to make sure that's inserted correctly. And notice that I don't get any warnings on the screen telling me that I have just put in a thumb drive. To activate anything on the WinFE program or Windows Forensic Environment, I have to right click. I'm going to choose the file manager. This is very important to do the first time you run it because I need to know where or what drive letter my Lexar collection drive has been assigned, and you'll notice that it's been assigned the letter D, and I need to make sure I remember that. It's very important. Now I'm going to go ahead and exit my file manager. I'm going to go right click again. I'm going to go back to my forensic tools, and in my forensic tools I'm going to launch a program you're probably familiar with called FTK Imager. Now once FTK Imager comes up, I'm going to follow the normal steps. I'm going to go to File, and I'm going to choose Create Disk, because we're going to do a physical drive capture. Now I'm going to choose my physical drive, and then I'm going to select Next. From the drop-down menu that shows up on the physical drive, there'll be 3 different drives. And you'll notice that drive 0 is an MMC, drive 1 is the Toshiba, and drive 2 is my Lexar. The 2 on the bottom there, those are my thumb drives. The MMC memory card, that 31 gig, that's going to be the drive internal to the computer. So I'm going to make sure I select that one, and then I'm going to click Finish. And that's going to bring me back to the option box where I'm going to choose Add. And from Add, I'm going to choose the EO1 file format. I'm going to hit Next, and now I'm going to fill out the basic information that I need to put into any case. My case number, evidence number, unique description, examiner information, and then I'm going to put in my notes. And it's really important that you put in notes. And we express this anytime we talk to the students, is letting people know what it is that you have for, or this capture for. Why did I capture? What's the point? And then I'm going to click Next. And when I click Next, I'm going to run into a small problem. And that problem is the drive that I want to save to is not going to appear. So when I click Browse, the Browse box is actually going to be empty. So I'm not going to see anything in there. This is where remembering drive D is important, because now I can manually enter that into my browse line. So I'm going to type in D:/, and that's going to path it to that collection drive. Remember that we saw that when we ran the file manager when we first opened up the FTK Imager program, or excuse me, the File Explorer program. Now I'm going to give it a good file name, something I remember. Again, this should be based on your unit policy or your SOP that you have for your agency. And I'm going to choose HP laptop, and called HP laptop stream, and I'm going to choose Finish. Now that I've got everything configured, I have my capture drive, I have my image I'm going to put on my capture drive, and I'm going to go ahead and select Start. And when I press Start, it's going to start the imaging process. Now we've sped this process up because it's going to take somewhere between 37 to 45 minutes to capture that 32 gig card inside of the HP stream. And you'll notice here in a second it'll jump forward. Yep, there we go. And then we're at the 37-minute mark. We verified our file to make sure that it is correct. The elapsed time, again, if you look there, it's at 37 minutes, so time warp has happened. Now we're going to check our MD5 hash. And the reason we're checking the MD5 hash is I want to make sure that the hash of the file matches the verification hash. And if we have a verification, it'll say match, and I know that I have a good hash. Once I've done that, I'm going to select Close. Now I want to verify that I've got the data collected in the ISO, or excuse me, the EO1 that I just created. So what I'm going to do is I'm going to add evidence, and since I created an image file, I'm going to select Image File. And now I'm going to go to Browse, and then I'm going to select from the D drive the evidence container, the .eo1, and I'm going to choose the .eo1 file, the very first one, not EO2, 3, 4, but the EO1. Don't get the text document because that gets confusing too. Once that's selected, I'm going to select Finish, and notice that in the upper left hand corner I will have my drive. I'm looking for a document that I put on here to verify that this is working. So I'm going to go into the root directory, and now I'm going to go down into the drive, and I'm going to look for a document. So it might be under Documents and Settings there, under my user. So I'm going to go to my users, and I see that I have my default user, and I have my public, and I have a warrior profile, which is my person that or my suspect. Now I'm going to go over to their documents, and in documents I can already see that there's a Quran and a couple of other documents of interest. So when I click on documents, I will see those documents appear over on the right hand side. Again, this is just using straight out FTK Imager, which I'm sure you are familiar with. Now I'm going to go ahead and close down my FTK Imager. I'm done my collection, and this completes the collection of this computer. Remove your parts. We're going to shut it down by holding down the power key, as we can't remove the battery. We're going to pull the cord, and we are done with this computer.